So, okay, we are live. Good. So, thank you everybody for being here. This is Amsterdam Clojurians Meetup number 83, I guess. So it's about 6 years of continuous Clojure meetups. So thank you very much for keeping up. And I see lots of new faces and lots of old faces as well. Anyway, so tonight we have an agenda. If you are familiar with this meetup, that's not always the case. But Vijay actually agreed to give a workshop about Onyx tonight. Who knows about Onyx? So a third half of the audience. Okay. So before we start, I just have just a shameless plug to make. As I left this picture over here. So I organize many meetups in Amsterdam, but I do also organize a conference that's called the Code Emotion. And that's going to happen. It happened the first time last May, and it was actually quite a fun event. Who was at Code Emotion last year? 1, 2, good. So you speak to the guys and you ask them if it was fun or not. Anyway, so I'm going to do this exercise again. It's a developer conference and anything goes. So it's not Clojure specific, but there was some Clojure last year. I do expect to have some Clojure the next year, and I cannot officially tell you what, but maybe not officially, I will tell you later on. And anyway, it's a nice conference where to be. So I just put a few pieces of paper and pens over there. We are going, the agenda is not live yet. The conference is in May, so it's a bit early. But we do have tickets already online. That's the blind tickets. So what we're going to do is actually to raffle 1 free ticket every month between now and next year. So if you want to participate and get a free access to our 2-day developer conference, just put your email there and we will spam you forever, for at least until May. Okay, that said, I would actually go ahead and invite Vijay on stage.
Yes.
So this should work for you as well. Absolutely, sir. So, okay, and one extra thing. I'm trying to be better at that, but I don't usually do that, but I'm going to stream this event on the internet tonight. I will try to do that for all the events. So just have a look on the Clojurians Slack, Amsterdam Clojurians Twitter, my Twitter, wherever, and have a look for the links for the Hangouts to join them. And let me just go back to there. Okay, so here we go. What was that? It works, good. So I'm not sure if we will be able to see the screen from the live stream. Let's hope so. We have 1 viewer, so welcome. Yeah.
Thank you.
Okay, let's see how this works.
Okay.
Yeah.
Hello. Okay, so
Jesus.
let's begin. Good evening. My name is Vijay, and today we'll talk a bit about Onyx. So the format of today is like a workshop because I think everybody wants to learn Onyx, not just sit here and listen to my rambling. So the idea is that I'll give a quick overview of what I know about Onyx. I'm not an Onyx expert. Obviously, there are a lot of people who raise hands. Can you raise hands again one more time so I can see who? Okay, there are enough people who know about Onyx, so there is no shortage of people who can give you help on Onyx. So that's pretty cool. So we can pair up later and then discuss a bit more about Onyx. So I recently saw something on the web that is about presentations. Like, how do you do a presentation? So the first thing is people are not interested in me, so they're interested in the content, right? So what is the problem that we're trying to solve here? So that's the problem. First of all, practically, I'm assuming how many people are here every day dealing with the data? Okay, right. That's cool. The people who are not dealing with the data, probably you don't realize that you're also dealing with the data, I think. So our essential problem right now these days is converting data into information. I don't know if there is any electronics engineers in here, so then data is basically the raw bytes, and then information is making sense of the data. So that's what we're trying to do. So that's our fundamental problem. Every day we're dealing with it. Now, obviously, this is too abstract. This doesn't make any sense. So let's pick a very concrete problem, what we're trying to solve. So assume that you have a website, and then you want to capture all the visitor information. Like basically visitors coming into your website, and then you see the logs, and you want to analyze something like how many people are coming to my website and what I'm from which location. You can see the referrer and then check where they're coming from. And if you're Google, you know what they bought 2 days ago. If you're Amazon, you can recommend them, I don't know, books and all that stuff. So this is one of the biggest things these days, that you try to collect as much data as possible and then try to process them. And then you want to analyze them, so you want to have some sort of a structured information around it. Because the data that you're getting from, they're completely unstructured, so you want to somehow put some structure into it. So how would you solve this problem? When you write a pretty simple program to, just type that in, you have log files coming from somewhere, you write a small program to parse all the log files, and you get one of those Clojure libraries to maybe if you're a bit more masochistic, you just go directly into JDBC, or you can use SQL or HoneySQL or whatever that is the state of the art these days, and then you push the data into that one. Of course, nobody uses RDBMS anymore, right? Everybody is into MongoDB or one of those NoSQL charts these days. So maybe you push the data into that one. So you write the program, and it runs perfectly on your computer. You deploy it onto a server, and you have a very tiny website. There are 200 people coming in, including you and your friends and a couple of other people, just like one visitor we have on this presentation on Google Hangouts. So everything is running fine. So there is no problem at all. So there is no problem of scaling. Now imagine that you have the data for a high traffic website. So high traffic as in thousands per second. Well, that's not high traffic. That still you can handle in one machine these days, even on your laptop. Millions of customers coming to your website. And then you need to process all those things in real time, because everybody wants to know in real time, and everybody wants to give you recommendations in real time. Everybody wants to track what is happening in real time or detect fraud in real time. Everything is real time these days. So you need to respond immediately. So how do you solve this problem then? So obviously the first hunch for people is that, sure, I'm going to do vertical scaling. So I'm going to just put more RAM into my machine. I'm going to put more processors into my machine. I'm going to put more disks into my machine. Has anybody any experience with this kind of stuff before? Did anybody do this thing before? So what is the maximum did you reach on a machine? Any idea?
I reached 156 gigabytes.
That's the RAM.
That's the RAM.
Okay, cool. So the place where I'm working at, we have 320 gigabytes of RAM and 64 processors. We ran out of all sorts of ways to put more data into that one, more disks into that one. So it's not possible anymore. And the worst part is the program is basically running in terms of putting all the stuff into memory. So if it dies, we have to load everything into memory again. So that's the fun part. So this, you do this thing, and then you're very happy. It's running smoothly. It's running fine. And then what happens is that, remember, the problem here is that you just capture the visitor information, which is very high traffic. Fine, no problem. And you just rip it off and then put it back into the structured data store. You're not doing any fancy processing. You're not doing anything interesting with the data. You're not doing any additional evaluation of the data, right? So that is so you scale vertically, and you're happy with that one. Now, somebody else comes in and then says, before you store into the structured data store, I want you to do more analytics on the data. I want you to correlate this one with the different things, because we have a data store somewhere else, and I want to correlate with that one. So for example, the website data that I'm getting right now, I want to correlate it with the ad spending that I'm doing. I want to correlate it with my CRM system that I'm having, like how many customers have already registered. And I want to correlate with some market intelligence that I'm buying by paying money. So they keep sending me market reports and like the demographic reports and everything. So there are two different problems now. Not only it's high fast data from a high traffic website, but also the processing stuff is now much more intensive, much more computing intensive. So you will reach some sort of limit. So there is going to be some sort of vertical scaling limit. You can't add more RAM because the machine cannot handle it. There is no way you can buy that one, and they're very, very, very expensive. Unless you're a bank or an insurance company, you can't afford it. So you can't add more processors. Obviously, you can't add more disks because there's not enough slots available to add. So everybody keeps telling me 12 is the maximum that we can put in. And industry-grade hard disks that you can get, that you can replace, are peaked at maybe 1 terabyte, and that is really, really expensive. So you're going to hit some sort of limitation. So it's basically vertical scaling. What other direction you can go? You can go horizontally. So you need to go with the horizontal scaling. So then you think, okay, I'm going to add more nodes. So this is the fundamental idea behind distributed computing, because you keep hitting the limits of a single computer or a single machine. So you have to distribute. So at some point, there is a trade-off between the processing that you're doing on a machine and the cost of distributing the data via network to different machines. There is going to be some sort of a trade-off. So then you need to pick up a distributed computing engine. That's the idea. So you say, okay, I'm going to add more nodes. So now your entire programming model changes, because remember, if you're running it on a single computer, of course, the multi-threaded stuff and all those things, that comes with a single computer, that's okay, or multiple processors, that's fine. But distributed computing is completely a different ballgame. So you need to think about what kind of tools are available, what kind of programming models are available for me to do distributed computing. So this has been research topic forever. So you can start with, I don't know, with all these kind of things available these days. There is in C++, there is something called MPI, I think, library a long time ago. That is for the distributed computing on different machines, how to send the data around and all that stuff. But it is completely mutable, pain in the ass, so let's not get there. So you have all these options right now. So you have Hadoop MapReduce, you have Storm, you have Spark, Flink, Scoop, Cascading, Cascalog, and there are a bazillion other things that are available to do distributed computing. So anybody has any experience with any of these things? Okay, which ones? Hadoop MapReduce?
Spark and Cascalog.
Okay, so Hadoop MapReduce is one of the granddaddies of distributed computing, or granddaddy in the internet sense, like maybe 5-10 years ago. So fairly simple idea. You take a bunch of data, and then your programming model is essentially a series of map and reduce operations. So they are independent, that you can scale up, you can send the data across the nodes, and then you can basically do the distributed computation, combine the data, and then store the results. But it is very slow because the way it is structured is that all the reduce operations need to wait for the map operations to finish. So there is a hard dependency there. Anyway, this is not MapReduce talk, so let's not get there. And there are other ways of doing things. For example, Spark is one of those latest hotness where it's basically in-memory distributed computing. So it will try to do as much as possible in the memory by getting all the data into memory, and then crunching the data, and then sending the data back to the any data store you want. And yeah, Flink is the real-time stuff. Anyway, let's not get there. So what's wrong with these technologies? So we have Hadoop, MapReduce, Storm, Spark, Flink, blah, blah, blah. First of all, they're not written in Clojure, so that is the fundamental thing wrong with them. Except for Storm, so there is a small star there. But they're trying to say, okay, Storm, we don't want to use it anymore, so we're going to Heron or something these days. With regards to that. So they're not written in Clojure, so that is the problem with them. Probably not. But there are even bigger problems. Like there is a very complex information model. So for example, if you're using Spark, which I'm more familiar with compared to Flink and others, you need to understand the programming model. You need to understand that Spark is driven by resilient data sets, or these days data sets, and then it used to be data frames, and then how it is going to partition, how is it going to distribute the data, and how you're going to deploy the system. And the programming model is essentially writing Scala, but not really Scala. So there is a bit of a gap there. It's not full Scala. You can't do all the Scala-related operations because every writing in Spark has to be serializable. Because it's distributed computing, it has to be serializable. It needs to be shipped to different places. So that's what I call like non-standard code. And there are differences in programming model for batch-based computation or batch processing and the stream processing. So the fundamental difference here is that batch is essentially you can take a bunch of data and then you write a program. It's going to deal with the data. The data is fairly static. So you can take some I don't know, in my case, let's say 100 gigabytes of data. Those are log files, and then you run a program on it, and nobody is waiting on the results. So you're pretty fine with the results. Having in 2 hours, you can come back and then check whether the report is available on your HDFS, and then you can take a look whether it is okay or not. So that's pretty okay. So that's the batch mode. And then you have the streaming mode, which is what we call this real-time mode. So I'm getting these events in real time, and I want to process them in real time, and then give insights in real time. So on a web page, I think it's basically ads and that kind of stuff people talk about, but there are much more I think sacred and holy use cases apart from just showing ads. So in our case, I work at a bank, and the idea is that in real time we want to show that, oh, you just did this transaction. Maybe you're interested in moving your money into this particular account, so maybe you'll get more benefit from it. And then analyze it and then provide real-time feedback to the customer. And much more interestingly, we want to detect fraud in real time. So we would like to block before the fraudster able to finishes the whole transaction. So that is one of the things that we're doing already with the existing technologies, but it is not scaling up the way we want. So that's why I want to go to distributed computing. So the streaming is another one where you can provide real-time intelligence. You can do real-time, like fraud detection is one of the use cases. And of course, in real time, you can do what they call ETL. So extract, transform, load, and then the data is available for the people to see what is happening. So you can put in some sort of dashboard in front of it, which is going to be probably Elasticsearch, Kibana sort of thing that the people can see what is happening. And then they can see, oh, wait a minute, there are too many requests coming in from, I don't know, Romania. Oh, sorry, I don't want to offend any Romanians, by the way. Maybe India, yeah. So I should probably offend myself. So there are too many requests coming from India, so they want to block a particular thing in real time because they're trying to DDoS our servers. So in most of these technologies, except for that's how they advertise. There is a difference between the way you can do the streaming programming and the way you can do that programming. How to MapReduce, you can't do streaming. There is no streaming because it's basically dealing with HDFS data and that's it. And write a Hadoop program that is going to get real-time data from Kafka or something else, like a event bus. So and Spark, you can do streaming, but it's not real time, so to speak, because it's called what they call like micro batches. So they do batches, and it's conceptually similar to the way we think that a CPU is running multiple programs super fast, right? It's doing a lot of switching, and then you only have one processor in the end. It can only execute one, but it is so fast that it looks like it is doing lots of things in a really fast way, and you can think that it is doing multiple things together. So Spark does similar kind of way. So it's basically batches the incoming data into some sort of a window that is time-based. So you can say every 1 minute I want to do this one. And then every 1 minute I want to know how many number of visitors are there on my website. So it's going to count on every 1 minute. Okay, I have 17 events, so 17 people. Well, 17 is too slow, but you get the idea. So that's the streaming idea, but that is the way Spark looks at streaming, which is essentially a special case of batching. But things like Onyx and Flink, they think batching is a special case of streaming. It's the other way around. So fundamentally, it is streaming. That means it can do really fast consumption of the data. And when you want to have a batch, it's basically waiting for some time and then creating a batch. That's it. But your fundamental programming model is batch. Then all you can do is keep reducing the batch size to a level where it would look like streaming. So that is the difference in programming model. So these are all the problems with how you deal, especially when you use different technologies. And the information model, I mean, how your program is going to look like, it's very tricky, because if you see any MapReduce program, have you ever seen any MapReduce program? It's like fucking huge. Oh, I don't know can say fuck.
You said it twice already, so.
We can't even bleep that out anymore. I apologize. Cussing, yeah, it's cussing huge. So, and you have to deal with all sorts of primitives that are coming from Hadoop because they call all the input data into input splits, and you need to worry about splits. And it's a huge Java program, and then you'll be back to the original Java la la land of just building huge program just to do a hello world. And check the hello world for all these things, basically word count, and you can see how big those programs are. And that's basically a poster child for Spark people as well. They have like 2 lines, then you can do whole counting. And then you're writing 2,000 lines in Hadoop. Well, I'm exaggerating, but yeah, we can do that, right? It's okay. So that is one of the biggest problems. So what's the point? How is Onyx going to solve all these things? So Onyx is built in Clojure. Obviously, it is solving the first problem. And then the other problems that we're going to talk about is the issue of information model, how it is going to look like. And I kind of feel like it doesn't need a talk. So that's why I had to fill in a couple of slides about the background. It's a very simple idea. I mean, people who are familiar with Onyx, I mean, you should already be knowing all this stuff. Like this is nothing. It's very simple to understand how Onyx behaves, or Onyx is built up. Maybe the guts of it is a bit more different. So the definition from Michael and Lucas is that it's a masterless, cloud scale, fault tolerant, high performance distributed computation system. So let's rip this apart. So we already talked about distributed computation because you have multiple machines. You want to distribute your computation by sending the data to different machines. They compute, and then they give the data back. You combine. That's basically distributed computation. Now, high performance. It's very difficult to say which of these machines, which of these programs are high performance because they're very, very dependent on the use case. Very, very dependent on the environment that you have. And it's very dependent on the kind of work that you're doing. You have to do exactly the same kind of work to actually check which one is high performance. But the primitives are there, which make sure that the program itself is fast enough. Now, fault tolerant. So we all know even the single computers fail. And the more computers you add, there's a more chance that everything is going to fail. And the tasks are going to fail. And the data, especially when you're dealing with unstructured data, that is going to be cussed up at some point. So you need to be very careful about fault tolerancy because whether you want to restart some computation again or not. So that is something that's very important. So Onyx does that as well. So it will try to retry the jobs and all that stuff. And cloud scale, well, this is one of those buzzwords. So it can scale to many number of machines. That's basically it. I don't know. Have you ever been on IRC on Emacs channel? If somebody says cloud, it will replace it with your butt. So if somebody says, hey, I have a new program in cloud, and then just the bot will automatically change it to your butt. But don't be on Emacs channel. So cloud scale is essentially you can scale it up to a large number of machines, and then you can coordinate it, and then you can distribute your computation. Cloud scale. Masterless. So this is one of the key elements that Onyx guys changed recently. I think from 0.9, if I remember correctly. So what is masterless? All these execution models, including the MapReduce things and everything, you do have some sort of a master or some sort of a supervisor which is supposed to distribute the tasks and aggregate them back and then see everything is okay. In Spark, you call that a driver, the driver program, and that is supposed to, so you submit your program to the driver, and then driver looks at the program, and then it decides, okay, I have 6 nodes available, or if you're using Yarn or some other resource manager, it will say, okay, I have 7 executors available, so I'm going to partition the data and then send it to 7 machines and the computation to them as well. They'll finish the computing, and at some point you want to collect the data back, and that's what the driver program is going to do. So in Onyx, it is all driven by some sort of a logging or a log. So it's basically a distributed log. So every peer knows, or every individual node knows which task they're trying to pick up. So Onyx is designed to be masterless, that in a way that it is supposed to increase the resiliency of the cluster, because there is no single point of failure. There is no single point of entry to the distribution, distributed computing. So what exactly you do with Onyx? So you build a directed acyclic graph of your entire computation. That's what you do. Sounds okay? Okay, next slide. No. Okay, I'll give you a simple example. So this is the simplest example. So here what we're doing is, I have some data coming in some format. And let's say I have some numbers coming in. There is a stream of numbers I want to process. And I want to increment each one of them and then send it to somebody else. Or just emit it into something. Don't worry about what this one and this one is. So it can be a core async channel. It can be Kafka. It can be Amazon S3. It can be a database where you're continuously reading from. Doesn't matter. Okay, so where we were talking about, like, I'm getting rapid data or fast data from the logs, for example, and then I'm going to increment a counter and then emit the counter every time, saying I have 7 visitors now, I have 8 visitors now, I have 9 visitors now. And this can be just a database where I'm storing this information. So how do you define this one? Because this Clojure and Onyx follows all the Clojure rules of simplicity. Everything is data. So your workflow itself, the workflow definition is just data. So this is the graph that you want to have. And this is what you're going to write. So it should be fairly simple. So in, increment, increment. So this is the common link between these two. And then this is going to go out. So it's a vector of vectors. So each step or each edge is in one vector, right? So a bit more complex thing. Now you're getting the data, and your manager or your product owner, if you're a Scrummy kind of person, or I don't know who project managers or whatever, or designers or somebody, or your architect, decides that the input needs to be processed in one way for one output and another way for another output. So imagine that you want to extract. So I'm getting all the web events. So that is essentially my timestamp and the browser identification, the user agent string, and operating system, or something like that, like 3 or 4 events that I'm going to get, and the URL that I'm going to get. Now, I want to get all the request and refers only into some other database so I can process them separately. And the rest of it, I want to push into another system. So the input is now divided into 2 parts, and then I'm emitting 2 outputs. So this is how your Onyx program is going to look like, or this is how you're going to define first. So here, this is the real graph, and this is what you're going to write in your code, which is again fairly simple. I have input. Input has 2 connections, so I have 2 vectors, input and input. They're going to processing 1, processing 2, these 2 parts, and then processing 1 ends up in output 1, processing 2, which is going to output 2. That's it. So this part is what we call the processing part. It is essentially a Clojure function. Then what exactly is flowing through these ones? So in the case of different systems, as I was talking about the information model, in different systems you have different types for these things. So in Spark, because it's written in Scala, so you send out RDDs. Well, you don't necessarily send out, but the system decides, okay, each RDD is processed by something. So it has a different model on top of it. But in Onyx, it's essentially a Clojure map. So the input is a Clojure map. You pass it to a processing function, and that takes the segment, which is the Clojure map, and then it emits a new segment back to the next step. So you are connecting all these things together in the workflow. Now you combine all these workflow things into a catalog. Is anybody familiar with Datomic here? Okay, so this is basically like a Datomic description of the data flow. So, well, not data flow, but it's based on that idea that you can define the entire catalog of your program into a simple data structure. So here, the one that we talked about, the input, increment, and output. So you can see those 3 steps here, which are basically 3 maps. Now here you can see input. Now we haven't specified what type of input is it. I mean, where is it going to get the input from? So in this case, in this example, I'm getting the input from core async. So there can be just a channel. So you don't need to actually write a program that is going to if you want to scale it into multiple machines, if you want to run it in a single machine. So even in your small program, you can use Onyx because it's just a library that you add in. So you're not writing Onyx programs, you're just writing Clojure program and then bringing in Onyx into your program. But if you're writing MapReduce programs, you are writing MapReduce programs. You're not writing Java programs. If you're writing Spark program, you are writing a Spark program. You're not writing a Scala program. So that's the fundamental difference. So in this one, this should be fairly simple. Well, I removed some of the superfluous things. There are a lot of options that you can give here. So this step is fairly simple. You can say this is the input type. So it knows that this is the starting node where the data is coming from. And the second step is incrementing it. And this is essentially a function. That's it. All your computation is just a function. So the function takes some parameters. Of course, you can well, we'll do that in the workshop anyway. So here you're going to say, this is my function that I'm going to pass whatever that is coming in, the map that is coming through the input, and I'm going to emit to a core async channel. So you can connect the data between two channels by a function. This is the simplest format. Now, you can create another catalog, then use the same structure here, but this one can be Kafka, this can be Kafka. Anybody used Kafka here? Okay. So Kafka is essentially event bus. Well, it behaves like an event bus. It's a distributed log, but you can use it as an event bus. So people can put data in, and there can be subscribers or consumers that can get the data out. So let's not worry about Kafka right now, but you can use Kafka as an input and Kafka as an output. And you can use Kafka as an input and a JDBC output. So you're pushing the data into a database. Or you can use Kafka as an input, and you can store the data into Amazon S3, the resultant data that you want to store. So the catalog is the one where you are separating the way that data flow is going to be, and your computation is the kind of computation you want to do. This is not easy in other systems. It's actually very, very painful. If I want to write a Spark program that is going to do all these things, you will resort to dependency injection and those kind of other horrors. So it's very tricky. Now, a couple of concepts I just want to touch upon before we get into the code. So the first thing is the segment. This is what I was talking about. So it's essentially the map that flows through this graph. So imagine this graph as a big pipeline of things. So the segments are dropped into input, and then they are flowing through the system, getting modified, and a new segment being emitted all the time. Then that goes to the next step, and then next step, next step. And here, we only added this one, but you're free to add, obviously, I think this should be very obvious. So you can keep adding any number of steps that you want in between. You can say this is processing 1. Then you can say increment multiplied by 7 and divide by something. And next, look up the data into some other database or from Datomic or from some other database, and then enhance the data and then push to the next step. So you can do all these things together. So those things are very easy. Now, segment is the one that is basically taking the data format, which is essentially a map, and that is flowing through the data flow graph. Now, who exactly is executing these things? So we keep saying, okay, data is going to flow through this one, but this has to be divided into individual tasks. Each of these function invocations, each of these input processing need to be delegated to at least other machine, because we're talking about distributed computing here. So that particular piece of work or the unit of work is called a task. So each time there is a new input coming in, that's a task. Each time a function needs to be invoked, that's a task. And each time you want to emit something, that's a task. So these are basically tasks that Onyx is trying to create and then manage them.
Can I ask a question?
Yes.
So the data that is flowing is Clojure maps, you say? But say I want to emit each second the average, or each minute the average. So how would I approach that? So that they're your functions? Should I make big maps with 1 minute of data?
If you're only trying to emit the average.
When it's streaming, I imagine to be able to keep some state of the stream.
Yeah, sure, you can keep the state.
These are functions, which I think.
Yes, these are functions, but there is a way to pass state back into the function. You can keep the state. You can, for example, if you want to calculate average, right? Yes. So every time you're trying to emit something, you can say, I'm going to reconnect back, and then say get. So it's a continuous function.
Yes.
Yeah. So, okay, so a task is basically any of these parts. It's a part of input, it's part of output, and it's also part of processing. Now, within this one, maybe even an increment, for example. In the increment, let's say the example that we had before. So here, you want to ignore if the incoming data is not even or not zero, something like that. So want to have some sort of a conditional flow. So because here, this is basically this is a complete dead flow, like a complete function. It behaves for all of the inputs. It's not doing anything. It's not ignoring anything. So you have a way to specify that you can attach a predicate at any step, and then say that from this input stream, when you are flowing into the next step, make sure that the data satisfies this condition. So it's basically like a switch in your circuit. So here what we are doing is, this is a flow control flow condition. So from the input stream, if you are flowing into increment, before that, make sure that the data that is coming in is even or zero. So only then let it flow into the next step. So you have a complete control on the data flow. And of course, all these things are executed on, in Onyx terminology, they're called peers. Peers are essentially physical nodes. So if you have, I don't know, so does anybody work with any clusters here? No? Okay. How many nodes do you have? Any idea? You're actually counting.
Configurable number.
Sorry?
A configurable number.
Okay. No, I mean like the physical machine, because we are using physical machines. So we have around 29 machines, like hardware stuff. Of course, if you are using VM, then obviously you can keep allocating. So each of those things, they're participating in a cluster. And then that is basically essentially a peer. So a peer is something where you send these tasks. So, okay, so you build the data flow and you build your program, which is basically a jar file. And then you say, okay, Onyx, start this one, and these are my peers. You can configure my peer addresses are these. And you can start distributing the tasks now. And then my data flow starts. When the data flow starts, there are events coming in at a rate of, I don't know, we have around, I think, 90,000 per 10 seconds or something, 100,000 per 10 seconds, or that would be 10,000 per second or something. Maybe that's the rate on a slow day in the mornings or something. So per day we have around 10 million, I think, events in the peak period, and people are sending their salaries or something. Or people are checking for whether my money is there or not. that kind of stuff. So so those events flow in, and according to the data flow, each of these steps are divided into tasks, and each task is now published in a distributed log, and the peers are going to pick up the task and then finish that one and then send the data back. So that's how the whole cluster is working in Onyx. Then
so task can move around. There's no dedicated peer for a task.
no, there is no. As far as I know, there is no affinity in the tasks. That's what I remember, but I might be wrong. I'm not sure though, because there is no.
You said pick up the peer will pick up the task.
Yeah, so there is no.
Dynamic.
Yeah, it's dynamic. I don't think there is any affinity that a specific task needs to go to a specific peer, because it's more like a commodity computing. So you want all of the machines to be, very democratic, so to speak. So if they are done, they should be able to pick the next task. That's the idea. Okay, that's a quick introduction of the concepts. Of course, there is a lot of stuff in the documentation. There is a much more detail. Obviously, nobody reads that, but I would recommend reading it. It's a nice read. There is a description about the internals of Onyx as well. There is a big refactor that happened in 0.9. The way switching into the masterless way of dealing with the computation, and the goal is that we will start with writing code, so people will get a hands-on experience instead of just listening to the stuff and okay, Onyx seems to be fun and whatever. But if you want to listen to Michael and Lucas talking about this stuff, I can recommend. There is a fantastic podcast which I should probably not say fantastic, but this is a podcast that I did with Mike and Lucas, essentially asking them all sorts of questions about Onyx and these things. I would recommend if you want to listen to this stuff. So let's get to the workshop, because when I asked them, what is the best way to do this, and there is already something called Learn Onyx repository that you can use, and it is very useful if you want to try it out. I don't know if anybody has tried it before. Okay, if people have tried, then please help us others as well. It's a very simple repository where you just need to fill in the concept that we introduced so far, essentially like a data flow and fixing the data flow, writing a function, and then making sure that the function fits in. And you get a hands-on experience of building and running an Onyx program. So then you, once it's around, I think 5 challenges or something, or 5 tests that we need to fix. So I'd start with, let me see.
Before we start, actually was thinking, so who came here without a laptop?
Yeah.
1, 2. Okay, so find a buddy.
If you want to use my laptop, you can just use mine as well.
Are the Wi-Fi details somewhere?
There.
Oh, yes. Sure.
So this is the.
No.
So this is the workshop. So the idea is that you get your. It's not visible light. Okay. Okay. So if you see, if you clone this repository, Onyx platform / learn Onyx, then you get so there are some challenges that you need to fill in. So there is a if you get the thing, it should be pretty. Maybe it's easier. So there are some tests, workshop, so challenge around 6. So each of these things talks about one of the concepts, like our workflow, fixing the data flow, creating your own step in the data flow, things like that. So for example, if you pick this one up, so you can start with, you can just run each individual tests. I don't know, depending on your editor or in line, you can say line test, just one name of the test, then you can run them. And please don't run all the tests without writing at least some code, because it will just blow up. So don't do that. And if you're using,
Who did it already? Nobody? No.
okay. So you can just run one test if you want. This is Emacs, and maybe people are using Cursive or whatever. I don't know. Sorry? Oh. Just use whatever editor that you're comfortable with, or if you just want to write it in Notepad, then open a terminal, then just open line REPL, and then you can just run individual tests by fixing the problems that you want to have. So take a look at the test, what it is doing, which should be pretty simple, and fix the source code. So in the source workshop, so for example, this one, maybe I should go with one. There is a fill me here, and what's that one? Fill me or something, or fix me. There should be something there. Yeah. So there is fill me in and fill me in. You just need to fill in the code there, and then you should be able to figure out. So how should we proceed? Should we do it from here, or do you want to pair up and then start on each of those things?
Yeah, I would suggest that everybody starts hacking, and maybe we can have a checkpoint in which we stop for a second and we show the results of the first. I saw that there's a challenge 0 and then 1, 1, 1 to 1, 3. Yeah, I would say let's complete all the challenges from 0 to 1, 3, and then we have a breakpoint. Okay.
Yeah. Okay. I'll walk around. If you need any help, let me know.
I will keep the streaming going even if we are going to do this. We have 0 viewers anyway, so nobody's going to complain. That's how this stuff go. I will actually get. Let me just. Yeah.
Who needs a computer or something?
Actually, me. Can I install Clojure?
Sure. I think there is a keyboard on this one. Because I'm running that shit.
All right, it's on.
Oh, my Onyx is a bit weird. That's half. Zoom might have,
Half film. It's Space Max.
yes.
I was talking to the Space Max guy. I'm maintaining one package on the Melpa for PlentyML.
Yeah.
It's PlentyML integration. We have PlentyML mode for Emacs. And I have my own version, and then there's the original code that has its own version that is ancient. So we're merging the two things, and I'm going to take over PlentyML mode, changing my name, and apparently SpaceMax ships with my mode.
That's sweet.
So yeah.
Because SpaceMax, the first Clojure mode I made that one for SpaceMax. Then I also fixed something and they gave me a patch.
What do you mean by that? Well, like physical one?
No. There is a so there are the contributions. They have the names of those things. Because there's something that says I fixed one of those weird Latin sayings or something, and they gave me the guy to fix the maybe my connection will be the fast Clojure mode and something.
You cannot show me the badge, you can show me your comment.
Yeah, that's what I'm trying to do. Yeah, so this is the first Clojure contribution I did a long time ago. And some advanced things. I did this one. That's like the other thing. So there is a Latin function name. I looked up. Somebody said, "Hey, that's wrong." That's this one.
Yeah.
So I did this.
That's actually wrong.
Yeah. It is like that. And then I fixed it as well. And I got here over here. And also, that's more fun. I really love these guys. And they know how to run up this fun. It's super fun. Exporting Latin language.
Right.
Well, I'm more proud of this one. Of course. It was the first.
But who was first?
This is the one that we did the first. But then people started doing it with my else. Yeah, so I have space max, so I don't know how
That means I have to press E before I can type.
No, you can switch to Emacs mode. If you type Control Z, then you're in Emacs mode. So I use a mixture of the things. Some of the things that I like. Yeah, so you're just now in Emacs mode. And, so we are in challenge 1-0.
I will just I will actually go around and have a look at how people are doing. And then oh, and you can do that one. You can give an example of what you Yes. Central building block. I know, but just so that people see that it is something else. Introduction.
Vijay, help us. Vijay, what is life cycle? So it's pre and post.
So life cycle is a life cycle. And what is everyone else is oh, it's better to start with challenge. For now, we'll focus them one by one. It's not and then square and then it's a very linear. So it's yeah, so this so each of these is a segment. So each segment gets into your so just one person. That's hard. So 0 1 is basically extra. 1 1 I like when people say fuck off.
You're still freely live, right?
Oh.
That's what you know.
I'm pretty sure YouTube guys are going to give us like explicit rating. Really?
Yeah, maybe that's like this is for yeah. Yeah, just to make sure that you understand something. Yeah, oh, yes. Right. Well, yeah, that's right.
Yeah.
Okay. Exactly what I want to do. Right. And then he was I remember so
So, all
how long do you do
yeah. Yeah.
Yeah. Oh, Java version.
Java version,
Yeah.
Clojure version, all those.
You probably need Java. Okay.
So,
I want to. I'm sure it was
No, that's easy.
okay. Anointing. Correct.
So we're gonna okay. No.
Onyx is much more open, much more yeah, it's streets. And also source inside, it's right down to source.
Maar het is altijd vragen. Iets met hier info dat is weer van speedfix. Een paar mensen
I talked to you on Slack.
Oh,
Perfect. So, you developed the inventor? Using it? Also, the expectation. You're using it for your own personal so it was a long, yeah. So those are very
Especially documentation and notice. I'd like to make a small layer of it's also in the back. Yeah. Very small. I never found. I'm one of our users, guys. So I love looking One of the things that we also talk about always looking out for yeah, looking forward to that. And let me know if you can have talks with the agenda and look at sort out where. Yeah, we can always yeah, that's it might be something I have to start experimenting with. Before I don't really know so it's very close by the area. And I was actually find some further places that it's just wonderful. I think also we have that place. A few people in this room, mostly people come from I'm not people from Harlem.
I'm excited.
Hey, profiling things. Sorry, sensitive information broadcasted to the world, but I cannot see them for anyway, so there's two topics. So it's yeah. Okay, let's take it back. So I will end in asking that question. Thanks very much. Yeah, please. Yeah. International is actually oh, very so maybe it's that's something better around that. So yeah, it's already and we can like about dash first and then we yeah, I can do some Yeah. My face with
That's essentially what they're trying to do.
Somebody else. It's Vijay. And it's not even Linux, it's space. Is here. Right.
The last one has only opened up. You get an email. It says you can leave now. Anyway. Yeah, please find something. Let's see if
We said like
Yeah, all good. I guess. It's not really Clojure. It's not really good. It parses the text per line, so it's really hard to pay attention.
you don't do, it doesn't do the
No, it's not spawn. I disabled most of the stuff from Clojure. I love programming Clojure every day. I work physical information. It's a kind of person. Now this is a museum. Actual we're mostly an airline today, so they'll think that the hotel platform is still below the front. Trying to do some Clojure there. Trying to do yeah. Whereas I guess more coders might see this on one design. So yeah, there was a lot of fun for me. So many people when you like 100 hours, you have to get them all in there and get all the right amount of data. Especially on mobile. So imagine like 100,000 names coming in. Yeah, so I have a filter on the 942, so everyone was red now, they died by 142. You can also see the story written about them, so you can see that a lot of regular contributions aside from all these people that like either a process or a user or a story. So you can see this one. It's all I tried like a zillion techniques to do. The only thing that worked was sketch enough, and then I just rolled the rest of the out. Oh no, I'm actually using one small component that's from yes. Okay. Creation for film. They have like a tiling calculation component where they don't need to calculate. It's just not you can throw numbers in it. So this is the whole visualization that's going to end up. Yeah, okay, that's fine.
Yeah.
For coders, I guess I'm the only one who does the element stuff. I built the position because I don't want to it's also nice if it's like a physical thing with it. You can just stand in the room and you can visit it on your mobile. And there's also those geo locations that I just ticker on the bottom of the visualization. It's as well. A person from New York is now looking at this person and remembering this person. It's really nice. No, this is just a visual installation in the museum. Well, if you're on your mobile, it'll just say Netherlands. But if you're on an actual physical connection, it will use the NextMind database where we put in an IP address. You get the actual location. Yeah, it's much bigger. Yeah, we do recognize, of course, the IP address of the museum. So if you're on the computer there, set say the museum, but mostly you just see it.
Walk next to something.
If you take out your mobile and go to the website.
No, I think
Oh yeah. So I'll zoom into a person. If I click on a person here, it will zoom into that person. That's what I want to do. This thing, because you cannot touch the wall. So it's not touchable. So it has to move or it has to. There's not much of an interaction, so that's why it's like slowly moving towards these people. And then we'll zoom into that space, move it around, to get an idea of how often it's very hard to get these words to blow up. Oh, here we go.
Yeah, so
They come in and zoom in, you know, try to catch those. Somebody
Okay, thank you for coming.
Yeah, of course. It's a long workshop.
Yeah. But good to get started. See you.
No, I was actually I don't want to be second packet, right? There's still but non te posso approcciare il vostro campo, il contatto
Okay, no.
Bye bye. Yeah, some names are.
Yeah, I put on my Wi-Fi in the train. So when I got here, especially with art.
Because of the text
Next one I'm going to try is
Oh, definitely, yeah. I saw it.
yeah. Yes. No, we had conferences. Yeah. This was actually at an event that we organized. Because we saw it.
Yeah, so one of the hardest parts
I was actually shocked to learn that behind the scenes of
this is maybe like one row.
Also the issues
Load it up.
Google share or
I know. If you wrote that in words, people would be like, oh, yeah, obviously.
So I know that
Oh, yes.
Those are hardcore. Badass. I got shell bomb on my.
you should have something like a secret injection
Yeah.
as a QR code.
Well, of course, I got the
No.
I got the have something. I'm kidding. We don't talk about it.
So that guy is
Yeah, it's really cool.
one there.
Very complex. Yeah, you gave talk about it. Taking the same steps as writing.
Yeah.
It's right now, no. What you described is I'm in the front row. It's really cool. It's really cool. You talked about ours, but I was the only one who there's so many fun ideas.
That's a lot of people.
Yeah, when he was talking about things like this, a friend of mine is so talk about all the questions. How are you combining all this? How much time do you have?
I try to get big into it. Exactly. Yeah. Exactly. Yeah, I actually see all the help now.
Let me know when you're coming.
That's not
The box is
Oh,
yeah.
I will get there slowly.
Just lost the point.
He's a good friend of ours. I spent like 2 days with him, but
Mitchell also is
I've seen it after the presentation. It was, makes me feel like
sometimes. No, seriously.
Everyone gets
I think
And I told him,
The game is very
looks good, it's fast.
and then there's no fucking way.
I've been doing Java for many years.
One thing we have to do is
We should be more used
Yep.
have fun on the
Good to see you again. And I think who thinks
Yeah, I mean, if you watch, I don't very much. So yeah, so I had first meeting with
with any player and was
the first thing I told
probably probably had they were taking as a sample for it and
then they're like, and the other thing was that if I wanted to,
evolution was I think yes, they have something.
well, but
I got like a guarantee that these are going to happen.
They develop some
I think it works.
I mean,
No, it's not the they really put it.
I'm just wondering if they said what's
their model has always been going through somewhat of big disruptions because they're consolidated. So,
I was a developer like 2 years ago, and the one that was the model tomorrow 1 o'clock. So this is good. Deal with it. Now here is so different. The optional.
Oh, yeah.
One of the things really fun people started using GitLab for their own projects. And then one day they're like, okay, now I'm going to use GitLab so especially out of and then the next thing started in the board start doing your stuff in GitLab. You don't have your own small empire of doing nothing on your own. But this it's not their competence. I was this way of working myself. That's very important because if I check this masters which works on Windows, by the way, able to do concept because here future proof.
And yeah, it was great. It's just like what you said. That's the same thing.
Because sometimes like it's always try to do something with application.
No, you don't do everything, man. Teams work on release in their life 1290. Where is the brain slow?
Yeah, so I want
Yeah.
it's easy. That's a collaboration between
Thank you. It's good to see us not taking good work.
Yeah, sure. No, I'm not Onyx, but I use Python there. On the other side. Yeah, that's like easy.
Oh, I get it because I've seen
But Onyx, I'm only playing with it on
trying to do something of something very hard. I don't know. I don't think there's much active development from Clojure. For example, other than public money in the project. It's no money anymore. But the software is open source, and I think it was together. I mean, it's typical allow discussion on stuff. So if you go up running and started doing optimization schemes with it.
I'm not that smart.
You have an admin panel or you can get applications and you get
so we know that
all the data
is complications and those nodes. What is very complex? Whatever I leave or so every other side they come.
So, I guess we are wrapping up, right?
Yeah.
Okay. Now, just to close the live stream, your stream for 2 hours now is going to be the most boring video on YouTube ever. Say goodbye.
People watch their Twitch crowd.
I think we might be much more boring than Twitch. I'm sorry. I'm sorry.
This is awesome.
Okay. See you next time then. Ciao, ciao, internet.